many kilometers above the ground. So this was the first impact first major impact we are known to have observed in human lifetime. And this happened in Tunguska, Russia. Have you seen anything like this? Here you can see a picture.
This is a trace of a meteor falling down when it goes across the sky because it has a lot of heat, because it had entered the atmosphere. That's why it's burning, and while moving through the sky, it has left behind a trail of gases and steam.
Ma'am, actually the friction of the meteor and our Earth's atmosphere, right?
Yes. So this is one of the major events which we have observed recently. In 2013, in Chelyabinsk, a huge meteor was observed entering through the sky. Okay, and you can imagine that this video or this GIF, let me replay again. You can see this GIF here, this video, where a meteor can be seen as bright as sun in the sky. And this video was taken from around 200 kilometers away from the place or the event location. So imagine how bright the meteor was and how big it could be, right? So a big space rock, a huge space rock came and it entered our atmosphere. As some of you just told me that when this space rock has friction with the atmosphere, it gets burnt, right? So at any evening or night, if you look at a shooting star is just a common term, but we all know it is not a star and it's just a dust particle. Whenever any dust particle enters our atmosphere, it gets burned due to friction with the atmosphere. And we can see a streak of light coming from the sky, and that is what we know as a meteor, right? So when these particles are huge, then such events, there are craters in the world, many huge craters like Barringer crater is there. Then our own Lonar crater in Buldana, Maharashtra is there. These craters are formed because of such impacts of huge space rocks, right? So let us go ahead.
And what was its diameter?
I do not remember the number exactly. I'll get back to you, sure.
Okay, ma'am.
Yes. Now, we talked about these events which we have observed and we have studied, right? So first event was this dinosaur extinction event, which occurred 65 million years ago. The whole species of dinosaurs and many species of animals or living beings in the oceans have been destroyed due to that event. Then a few thousand years ago, this Barringer crater happened. Then Lonar crater is also a few million years old. Then the recent events was Tunguska event. Then there occurred this Chelyabinsk event. One of the major things we observed in Chelyabinsk event is the shock waves also were so powerful that many of the houses or the glasses of windows and doors got shattered. And due to that, more than 1,500 people got injured. This was the impact of that event, the Chelyabinsk event. So we know that these space rocks, when they are huge and they come to us, they are threat or hazards to us. And that is why scientists or astronomers all around the globe are looking for such objects which can pass through or near the orbit of the Earth. and they keep an eye on every space rock possible 24/7. They are looking for near Earth objects or potentially hazardous objects. And this is how our mission of finding out NEO or near Earth objects and potentially hazardous objects have been started, so that we can save ourselves, we can save the Earth, life on Earth. Now, if you have heard about DART or DART mission,
Double asteroid redirection test.
yes, very good.
Yes,
very
ma'am,
good.
I have heard.
So it's double asteroid redirection test. And this is for, okay, I cannot hear you properly. Can you please say it again? Who is talking? Ransh, you want to say something? You have raised your hand.
Students, can we do one thing? We will listen to ma'am first, okay? We will listen to ma'am first, and whenever ma'am asks you any question, you raise your hand and ma'am will ask that person. Ma'am will select the student, okay, who will give the answer. Can we do that? Yes, yes or no? Show me the thumbs up. Yes or no?
Yes,
Yes.
ma'am.
Very good. Yes, so we will listen to Sonal ma'am first, and then we are going to ask the questions. Okay? Yes, ma'am.
Yes, thank you. So the recent mission on 26th September 2022, this DART or double asteroid redirection test, this satellite or spacecraft crashed onto one of the asteroids in our solar system. And the name of that asteroid was Dimorphos. Here you can see a picture of the asteroid system. So it was not one asteroid, but it was a binary system. One asteroid revolving around other asteroid. So it was like a moonlet of the asteroid on which we have tried this test. So here you can see Didymos, which was the main asteroid. This is, by the way, one of the near Earth objects. But thankfully, it is not passing so close from the Earth that it can be a potential hazard to us. So we chose this object. And last year in 2021, around 10 months ago, the mission that was launched. On this 26 September, the spacecraft, you can see over here, the closer view taken by the spacecraft of the Dimorphos, the moonlet of the asteroid Didymos. And it crashed on this satellite, asteroid. So why we did this test is because we now know the hazards to the life on the Earth. And these potentially hazardous objects, any space rock that is approaching near to the Earth can cause harm to the life. And that is why what we are going to try is, we are going to try to redirect these objects before they become any hazard to us. And how it is done? So, sorry. So how it is done, let me show you one video.
Ma'am, so its main purpose is to finish the asteroid off when before it comes closer to Earth, right?
Yes, not exactly finish, but it redirects. Okay, so let me show you a short video, small video. We can see a time lapse over here. Okay, this time lapse is taken by the DART. As the DART is approaching near the system, you can see the asteroid getting closer, and the DART is now passing by the asteroid, and it is going towards the moonlet, which is Dimorphos. And now it is crashing on it. Now, the students who are from 9th standard here, they might remember that there is something called as law of conservation of momentum.
Yeah,
9th,
ma'am.
12th standard. Yes, very good. So the law of conservation of momentum, if you remember the formula says, सबसे पहले तो first of all let us talk about what is momentum. Can anyone tell me? Please raise your hand. What is momentum?
Something that happens.
Something that happens. Okay. Anyone from 9th to 12th standard?
Ma'am, it is the product of mass and velocity.
Yes, very good, Ved. So it is the product of mass and velocity. So if we consider m as a mass and v as velocity, then m into v is the momentum of the object. Okay, the object is moving with some velocity v and it has mass of whatever m kg. Okay, now what the law of momentum conservation says is that the total momentum of the system, the total initial momentum of the system is conserved after the collision. Means the total initial momentum of both the bodies, if two bodies are considered for collision, then the total initial momentum, the addition of both the momentums is equal to the total momentum of the system after collision. Means after collision, the momentum is going to change. If you observe these collisions, when you are playing cricket, the ball is slowed down, or when you get a shot, right? When you hit the ball with the bat, you can see the change in direction as well as speed of the ball, right? Similarly, when you
Yes,
play carom, right? So that time also you can observe these collision of two systems, okay? And you can actually observe how the speeds are getting changed when collision happens. Sometimes what happens is one object stops when it hits the other object and it imparts all its momentum to the other object and it gets moving forward, right? So this is how momentum conservation works. And we are using this to slow down that near Earth object. How it is going to be done is like a satellite or spacecraft, which is our rescue satellite or rescue spacecraft, with certain mass. Let us say M2. Okay, M1 is the mass of this huge asteroid. M2 is the mass of satellite. So earlier, the asteroid is moving with speed of U1, and the satellite is moving with a speed of U2. When they collide together, now remember, the spacecraft should collide with the satellite in opposite direction so as to slow it down. If it collides it from the same direction, then what is going to happen? The momentum are going to get added.
Yeah, so it will
Yes.
it will become more deadly and
So if we want to change
It will
the
become more
velocity and speed will increase.
yes. So we have to change the direction of this asteroid. So what we have done in this case is we have collided our DART spacecraft with this Dimorphos in opposite direction. And when it collides with the other object in opposite direction, what is going to happen is it is going to slow down that object, okay, by a fraction of the speed. Okay, whatever the original speed of this satellite is, it is going to slow it down. And as it is slowing down, the orbit automatically changes. Because if you remember or if you observe, the moon is in its orbit around the earth because it has certain velocity, certain linear speed.
Centrifugal force.
Yes, and if this speed by any factor, if the speed gets reduced by some factor, the moon is going to spiral down. Okay, the moon is going to spiral in. So this is what we are doing. we are trying to change the orbit by slowing down this object. And this is what the dart is going to do. And how are we going to observe if this huge asteroid with humongous speed is slowed down or not, right? So there are many satellites. Let me share the screen again. So you can see there are many telescopes almost across every continent which are going to observe this this asteroid continuously. Okay, there is a telescope in Australia, New Zealand, Antarctica, South Africa, right? You can see everywhere around the globe. There are many telescopes which are observing the system of Didymos and Dimorphos. Apart from that, there is Hubble Space Telescope, James Webb Space Telescope, as well as Lucy. So these space-based telescopes are also going to observe this system, and they are going to tell us in a period of certain time. We do not know exactly when this is going to happen, as this is a test, right? This is the first ever trial of the theoretical idea of slowing down the object. Okay.
Ma'am, near camera is used in James Webb Telescope, right?
Yes, yes. So James Webb Telescope is also going to observe these asteroids. And then we do not know for sure when it is going to happen, but we will certainly get some inputs from all these telescopes across the world, as well as from the space, that if the test has been a success or not. Now, let us go ahead and get to the last part of the session, which is challenges in the space technologies. Now we know that how space satellites can be rescued for us, right? They are rescuing us by telling us the weather forecast. They are rescuing us by tracking down the distress signals. Now we are trying to find out a solution or to test if they can rescue us from the huge space rocks too. Now there are other challenges in this space technology, right? Of course, there is protection of humans, like astronauts are going into space and then they get exposed to the cosmic rays and all. So how we can protect them? Then there is another challenge which is bigger, that low cost space technologies. We know how much amount is behind each mission, right? So how to make it low cost? Then there are large space structures. These spacecrafts are huge and they weigh around more than 500 kilogram or something, right? So how to maintain these structures and how we can deploy such satellites effectively in the space. Then there are, of course, the major challenges which are related to in-orbit servicing and active debris removal. So you might have heard that there is a huge space debris around us because the satellites which have stopped working, which are not in use anymore, are still revolving around Earth. We do not know what happens there.
Ma'am, space debris can be dangerous, right? Means
yes, exactly. Space debris can be dangerous. Sometimes if sometime the collisions occur between two satellites, suppose.
Ma'am, many of the smaller particles hit the spacecraft, so it can cause a huge amount of damage.
Yes. So they can cause the damage to the working spacecraft as well as if they fall on land, okay, where humans are there. So they can also harm us, just like the space rocks. So these are some challenges. But one of the challenges about last space structure is right now getting taken care of, or people are trying to manage or to find out new technologies to deal with these last space structures. Let me show you one video. And yeah, this is a video which I'm going to show you is of the solar array, which we have used in DART. Okay, so let me play the video. It has a sound, so please listen to it. They're explaining how it works.
We're here to do the final flight inspection of the rollout solar array, or ROSA, that will go on the DART spacecraft after these are shipped to APL in Laurel, Maryland. We're at Deployable Space Systems in Goleta, California, right outside of Santa Barbara. The next couple of days will entail the final cleaning, the final inspection of these arrays. When they're rolled out and fully deployed, they're almost 10 meters long. This is the last time that anyone will ever see these arrays fully deployed. Once we stow them here at DSS, they will not be deployed again until we're in space on the DART spacecraft. Part of our detailed inspection entails Andrew looking at the cell by cell on these arrays, again, that are almost 10 meters long. He'll look at them at different wavelengths of light, different angles, just to assure ourselves that we've found every anomaly possible in these cells and they're fully characterized with the entire array. And we know exactly what we have and the condition it's in when we launch. DSS has flown a rollout solar array as a demonstration on the space station. However, this is the first flight mission that rollout solar arrays will be used on for NASA.
So this is how we are right now trying to think in different ways that how we can deal with these challenges. You can also check for how space debris can be managed. So there are many space agencies who are working on it. They also there are also sometimes some competitions for ideas where you can share your idea or make a model how to manage the space debris, how to collect the space debris and get it back to Earth to destroy it in a proper way. So these are some of the challenges, and with that, let us just summarize this what we talked about today. So we talked about what satellites are, then what are the life purposes of satellite and how different kind of satellites help us in different areas. And then we talked about how these satellites are always there on a rescue mission. And at the end, we saw what are the challenges of the current space technology. With that, I would like to stop. Thank you everyone for listening and a very good response and keeping it interactive. Thank you.
Yes, ma'am. Thank you. Bye, ma'am.
Ma'am, I had a doubt.
Bye, ma'am.
Thank you. Bye, ma'am.
Anybody wants to ask their doubts one by
Yeah,
one?
ma'am.
If you have any
you can
questions,
ask.
please raise your hand.
Bye, ma'am. Thank you, ma'am.
Children, I hope you have understood. That is the reason that you are saying bye. Means today you do not have questions, right? All the curiosity is done by Sonal ma'am.
Ma'am, I have.
Acha, okay, fine. Please go ahead.
Yes.
Ma'am, which programming language is preferred the most for space science field? Actually,
Who is it? Can you please tell your name?
ma'am, Arham.
Okay, so actually I do not know about it. I will get back to you when I'll look for the answer, and then I will share the answer with Archana ma'am. Maybe she can share it with you.
Okay, ma'am. Thank you, ma'am. Bye, ma'am.
Bye.
Bye, ma'am.
Does anyone have any other question?
Bye,
It's
ma'am.
me, ma'am.
Anybody wants to ask
Bye,
any
ma'am.
questions?
Bye, ma'am.
I have a doubt.
Bye, ma'am.
Bye, ma'am. You have a doubt.
Ma'am, I have a doubt.
So those who have
Students?
doubts, please raise your hand. And you, yes.
Yeah, and please
Yes,
no
Ved.
need to say bye, ma'am, ma'am. You all can leave if you don't have any doubt. If you want to ask any question, you all can switch on your mic and ask your questions.
Ma'am, I have a doubt.
Hmm.
Yes, who is speaking?
Ojas.
Yes, Ojas.
Ma'am, I don't understood navigation part.
Navigation part?
Yes, ma'am.
Okay. So let me just show you that slide again. Just a moment. Okay, can you see the screen now?
Yes, ma'am.
So here you are. Okay, the red dot on the earth, it's you. There are many satellites already around the earth. Okay, they are moving around the earth and there is a constellation. So this is called as constellation of satellites. If we talk about global positioning system satellites constellation, there are 26 satellites right now revolving around earth who are keeping an eye on you. So whenever you turn the GPS on and you track someone, okay, or something, suppose you are tracking the delivery of pizza you have ordered, right? So when you are sending the signal or the GPS, right, that signal is reaching the satellites which are in the visible range. Here you can see there are 7 satellites which are visible, right?
Yes, ma'am.
Yes. So these are getting signals from you. At the same time, the signal, suppose pizza is from a few kilometers away from your place. So their transmitter is also sending signals, right? And they might not be, all the satellites might not be the same, right? The satellites which are observable or observing the pizza guy might be different, but they are also sending the signal back. And when the positions of these satellites are going to track your position, and when there are at least 3 satellites, consider this one satellite, this satellite, and this satellite. Okay, they are occupying different positions in the space. Now, these are tracking you down. This satellite has tracked you here somewhere. This is the circle this satellite is tracking you. Then this satellite is tracking you in this circle. Now there is going to be an overlap of these 2 circles. Okay, so the probable area is now reduced to only this. Now the third satellite comes into picture, and this third satellite is tracing that this is the area where you are in. So of these 3 circles, there becomes the smallest possible area where you are right now, or the pizza person is right now. Okay, and this is how we get the accurate position, which is chased by at least 3 satellites. Okay, but we have almost 6 to 7 satellites all the time watching over us and tracking us. And this method is called as triangulation. So you can check out for this word triangulation, and using this we get the tracking.
Ma'am, means on Google Map also this is used.
Yes.
Okay, thank you, ma'am.
Welcome.
Bye, ma'am. Have a great day.
Same to you.
Anybody wants to ask any more questions?
Excuse me, ma'am.
Yes. Who is it?
Ved, I myself Ved here.
Yes, Ved.
Ma'am, about that DART mission, the name of the camera was Draco, right? Which captured that test image.
Yes.
Okay, ma'am. Thank you.
Priyanshu, do you have any question? You have raised your hand.
Naman Naidu, Priyanshu.
Yeah, ma'am. So as you said that yeah, ma'am. So as you said, means satellites. Satellites are used to track. I mean, some of the satellites, especially built to track down the people which are missing. But suppose if you don't have any mode of communication, like suppose you don't have a like a radio or a mobile, then how can satellites track you? Like, can they? They
So
can't.
that comes a problem, right?
Yes.
There comes a problem. If you do not have a device to send that SOS distress signal, then nobody will know. So then come the other ways, the ancient ways, right? Like putting a flag on or fire on, like ancient people used to do. So,
Ma'am, but
yes.
ma'am, but suppose can satellites be made? So suppose satellites can use cameras to track down means just see over the oceans, and then they can like see if any ships are missing or like something.
Yes, that is done. But for
Priyanshu.
that, it should be known that there are ships, right?
Priyanshu,
Yeah.
there can also be another solution to this problem. We can have what do we call some tourist places, high places where tourists go. We can, once they enter the reserve, we can give them a small device that can give their signals. We can give something to them that can be a major solution all around the world.
Yes, very nice, Krish. So again, you are using a device. So Priyanshu's question was if device is not there,
So
right?
device should be there.
Solution, it should be there, right? Yes.
Yes.
Naman, do you have any question?
Yes, ma'am.
Yes.
Ma'am, I don't understand how the solar array help to reduce the debris.
No, solar array is not for reducing the debris. It was just shown to how we are dealing with the large scale structures. So the solar panels were rolled in, and when they were deployed in the space at a particular height or in a particular orbit, then they rolled out. So that is how we are managing the space, right? So that
Okay,
was dealing with a large scale structure problem.
Okay, ma'am.
Yes. Arush, do you have a question?
Yes, ma'am. Ma'am, if does satellites take a photo of galaxy? If the answer is yes, then how they take the photos and inform the scientists?
Okay, very nice question. So I'm happy that you are asking so nice questions. So there are satellites which are there for astronomical purposes, right? Like our own AstroSat. So these satellites, what they do is in the space, when they are in space, there is no day and night, right? So it's dark around. So they can observe a particular object. It can be a galaxy, and then they can simply capture. They can, as we use our digital cameras, right, DSLRs, there we manage the exposure time and everything, right? Aperture, exposure. Similarly, these cameras also have an exposure time, which is defined for different objects. If the object is bright, the exposure time will be very less. If the objects are fainter, the exposure should be higher, right? So those are set for those objects, and then they capture many images. They are stacked together, and then these are sent via signals, right? So this is how satellite communication works. So in the radio signals, as radio signals can penetrate the Earth's atmosphere, we use radio signals to communicate with satellites. Okay, so these satellites send this data in the form of radio signals. It is coded now. Okay, these signals are coded. These signals reach the Earth-based systems or receivers. We are receiving the signals from the satellite, and there the data is decoded, and then we convert them into images. Okay.
Okay, ma'am. Means in short, the satellites have a digital thing that captures a camera
Yes, yes.
photo. Okay. Thank you, ma'am.
You're welcome.
Anybody else have any questions?
Yes, ma'am.
Yes.
Yeah.
Ma'am, I have heard sometimes that because of sunlight, a meteor changes its direction as it releases ions and it changes direction. So there's a myth that if we paint the asteroid white, so it will not means absorb ion. It will release ions, so it will not turn the direction. So there's one more way. So is it real?
I haven't heard about it yet or haven't read about it yet. So I'll have to check, but
There's a so how the universe works. So in that I have heard.
Okay. So let me check if this is true, because I haven't heard about meteor changing its direction because of sunlight.
Because of sunlight, it gets heated and it releases ions. So it changes its direction, opposite to the ions.
Okay. I haven't heard about it or read about it. So I will check about the facts, and get back to you.
Okay, ma'am. Thank you, ma'am.
Welcome.
Anybody else wants to ask any question? Any questions?
No.
Yes. Yes,
Ma'am,
Krish?
Ma'am, I heard that this is a what do you call in relationship with the Space Week program. So I just wanted to ask that are the what do you call competition entries on my side given from my side?
So you have registered for which competition, beta?
Ma'am, poster making and story making.
Yeah, poster making and all. So for that result, you will be getting it on Monday.
Yes, ma'am. And but there is one thing in the story making competition. I did not write all the details in it about myself.
Okay. But did you enter your phone number?
No, ma'am.
Then what you have entered?
Ma'am, in the PDF name is My Solar Project dash Krish Sherpa.
Okay, we'll check it and get back to you.
And the other poster making, I did give all the details. So can you link it?
Yeah, we will.
Thank you, ma'am.
Anybody else wants to ask any question? Okay, so I deem it a great honor and a privilege to propose a vote of thanks to ma'am. And on behalf of Ashoka Group of Schools and the entire team of Astronomical Observatory, I'd like to thank Sonal ma'am for such an innovative and inspirational session. So thank you, ma'am. Thank you very much for giving us such an informative session and addressing our students and clearing the doubts. So thank you very much, ma'am. Yes, Archana ma'am.
Thank you, ma'am. Bye, ma'am. Good evening, ma'am.
Thank you, ma'am, Sonal ma'am, and see you. We would like to have you physically here in our school sometime.
Yes, sure. I would like that.
Yes. So actually, we were planning for such thing, but I got like from Rupesh sir while discussing. So thoda sa ye nahi ho paya. But maybe when you are free that time, you just let us know.
Sure.
Huh? Yeah.
Yes.
Thank you so much.
Thank you, everyone.
Thank you, ma'am. Thank you very much.
Thank you, ma'am. Bye, ma'am.
Thank you, ma'am.